a sample of 100 passengers shows that 60 survive. Now, is this looking for mean? No, it's looking for fraction, right? Fraction, aka proportion. We want to know, is it true that 60% survive? Yeah, 60% survive. That's whether the population proportion of the survivor is 0.5 at a 5% significant level. Wait, doesn't this look funny? You see, this is 50%. But the formula, but the value data given here is from the sample. Actually, the number of passengers is not 100, no? Many, yeah? Many. But we're just saying 100 passengers, 60 survive. This is the sample proportion. Sample proportion, 60%, 0.6. The 0.5 here is not sample proportion, but population proportion. And then the alpha value is 5%. Alpha value is 5%. And then what do we do first? We come up with a hypothesis. So since this is one population, we'll be comparing this population with the standard population. Okay, with the normal population. Okay, which is there any difference between this sample population, sample proportion with the population proportion? Sample versus population proportion. That's what we are comparing. So now hypothesis says same. Now hypothesis always say same, no difference. Now hypothesis is always like that. Yeah, you don't say now hypothesis that there is a difference. The answer is no difference. Any now hypothesis like that, and then you get the value of z. So how do you get the value of z? You need the p estimate, right? Point estimate, which is 60%, 0.6. And then this P0 is what? This is the population proportion coming from 0.5. So you just plug in 0.5. And then what is N? N is the sample size. What is the sample size? 100. Yeah. So by doing this, you will get the calculated Z. We compare this calculated Z with the critical Z later. Now, how do we get the critical Z? You use the calculated Z, refer in the table in order to get the critical Z. Then you use your calculated Z, compare it with the critical Z. Your calculated Z, if it's bigger than the critical Z, reject the hypothesis. Okay, for the first question, it says there, a sample of 100 passengers, N is 100. This is sample size, not the population. Okay, and then it says that 60%, 60 survive. 60 out of 100 survive. Thus, the point estimate, okay, will be P divided by N, 0.6. And then it says there, the proportion of survivors, yeah, the proportion, the population, keyword is population, not sample, proportion of survivors is 0.5 at significance level 0.05%. Okay, so the question is test the proportion. So how many samples are there? Okay, one population. So we'll be using the one population formula. First of all, we need to figure out the hypothesis. We want to say that the sample proportion is similar to the population proportion, i.e. 0.5. Yeah, because the population proportion is 0.5. The sample one is 0.6. I want to say that the null hypothesis is that is similar. Okay. So the next step is to get the test statistic, which is given by the formula sample proportion minus the population proportion divided by the square root so we just populate this because we already have these values, right? 0.6 minus P0, 0.5 square root of P0 is 0.5. 1 minus 0.5 is 0.5. Divide by n is 100. Let me use calculator. Zero point zero 0.05. One divided by 0.5. It will give us 2. Okay. So Z here is 2. The calculated test statistic is 2. Now, we want to find the critical value. Yeah, I need to refer to the table. So you see, because the critical value is given by Z alpha. Okay, so alpha here, if is a single tail, use Z alpha. If double tail, use Z alpha divided by 2. Okay, so when do we use single tail? When do we use double tail? So the indicator for this is look at the hypothesis. Now, whenever we see the null hypothesis being equal, yeah, not greater than or less than, then we use double tail. Yeah, the only time we use single tail is when we see something like this, either this or this. Then we use single tail, but this is not the case. So we'll be using this one. So the alpha value is given by 0.05, right? Yeah. Therefore, we're using critical value Z alpha divided by 2, which is now I'm going to look up the alpha. Yeah, 0.025. 0.023. Okay, and then it says how there's still alpha here, 0.025. 0.025. So I take the Z alpha. I take the Z alpha 1.96. Yeah, 1.96. Now decide. So we take the test statistic versus critical value. Okay, so test statistic versus critical value. Test statistic is 2, and then critical value is 1.96, and then the verdict is that it is greater than 1.96, right? If Z is greater than critical value, then reject null hypothesis. Since above is bigger, right? Then the sample proportion is same as population proportion is rejected. Okay, so that would be the answer. Example 2. Okay, ready? Okay. Move this side. Compare the survival proportions of males and females. So we have a male proportion and female proportion. You see the male proportion, they are 50 people, okay? 20 survive, 30 die. So this is sample only, because the actual population is much bigger than this, yeah? And then for the female, also 50 people. Here it mentions that 40 survive, then die. Now, we are interested in this proportion. So for the male, so the estimated point, yeah, for the male is we are interested in survive one. The die one we're not interested. 20, because the question is saying is asking us to determine the survival proportion. Survival proportion. Survival proportion. Okay, 20 out of 50, which is about 0.4. And then for the female, 40 out of 50, which is 0.8. All right, so I just write here, male is 0.4, female sample is 0.8. Okay, and then it mentions also, yeah, I just put for the rest, male 50, and then the survive one for male is 20, and then for female is also 50, and the survive one is 40. Significance level usually is 5%. Okay, so let me explain what happened. I already acquired all the data from the question. Okay, this is where I stopped just now. Then the hypothesis is that, remember, null hypothesis is always that there's no difference. Null hypothesis means there's no difference. So therefore, there's no difference between male proportion of survivors and female proportion of survivors. So I put that equal. You see, the male one, same as, I mean, obviously it looks different here, but we need to test at population level, whether this is sample level. Yeah, this sample level, we want to test at population level, right? So we equate them. This is a null hypothesis. Okay, the first step is to come up with a pool proportion. The formula given by pool proportion is PM plus PF divided by NM plus NF. Okay, and PM is the number of survivor of male, 20. PF, female survivor. NM, total male. NF total female. We do the maths, we get 0.6. Okay, then we go to the test statistic. Remember, we want to get the test statistic, right? Calculated statistic. So the formula as given in the question just now, yeah. Male proportion survive, female proportion survive, okay, minus them, and then square root of pool proportion, multiply 1 minus pool proportion, multiply 1 over total male, 1 plus 1 total female. Once I do the maths, I get negative 4.08. Okay, so that is step number 2 for getting the calculated Z. Step number 3 is to get the critical value, the critical proportion value. You see the hypothesis says equal, right? Equal, right? So use two tail. Take the alpha, divide by 2. So alpha is given by 0.05, right? Thus, alpha divided by 2 is 0.025. We'll be using this one. You want to find the critical value from the table. D. So this one you need a table. See here, percentage point of the normal distribution. Inside here, alpha. So inside on the left hand side, alpha. This side is the critical value. Yeah, Z, critical Z. Alpha, critical Z, alpha, critical Z, alpha, critical Z, alpha, critical Z, alpha, critical Z. So we have the alpha 0.025, right? 0.025. Okay, again is 1.96. Okay, 1.96. So now we can decide. Just now we have figured out that the Z, the test statistic of Z, right? We must take the absolute value. We don't care about the negative. Yeah. You see this? Yeah. From the test statistic earlier on, this one, we take the absolute value. Okay. We want to compare it with the critical value. So what is the relationship? So 4.08 and 1.96. So it's bigger, right? Yeah. If it is bigger, we reject the null hypothesis. Okay, we reject the null hypothesis. Yeah. Thus, you can say that the male proportion and female proportion not the same. Of the Titanic population are not the same. That means maybe more males survive or more females survive. We do not know. It's just that we know that they're not the same. Okay, based on this analysis. All right.